This video is to introduce the paper Mining the Cost of Political Decision-Making from Social Media, a case study of COVID-19 policies across the US states. This is a paper at EMNLP 2021 findings with the joint collaboration among Max Planck Institute for Intelligent Systems, ETH, MIT Political Science, IIT Kharagpur, and University of Michigan. I am Zhijing, and I also want to thank my other wonderful co-authors, Zeyu, Tejas, Bernhard, and Rada. So the key question in this paper is, are politicians overfitting short-term public opinions? And this paper is part of our overall goal of pursuing NLP for social good. Specifically, this serves to detect and report important social issues. So this research question is inspired in 2020 when we see the tweets of US president about liberating Virginia, Michigan, and many other states. And each of the tweets get a large number of likes and retweets. And this is also like sort of a question that got a lot of attention in the news as well. Like a BBC News would write on the topic of, are some states lifting restrictions too soon? And specifically, our paper concerned about the question of why, like why do politicians make such decisions? So to formulate the problem, we want to find variables that quantify each of the elements in this research question. One variable we get is COVID-related tweets in a scale of sentiment -1 to +1. And then the other variable about political decision-making, we get the social distancing policies on a strictness scale of 0 to 5, where 0 is like fully reopen the state and 5 is like totally close down the state. Moreover, we need to consider the confounders, such as COVID cases, which might also affect the policies. So there are 3 steps in this paper. First, to nail down the data. Second, to conduct the causal analysis. And third, to link back to real-world politics. So when looking into the data, we collect data about all 50 US states. And for each of the states, we collect the variables that we're interested in. For example, the COVID case number is a public data, and also some other confounders are easy to obtain as well. Whereas the 2 other variables are harder to obtain. So when looking into the US data, we also need to pay attention to governors' key role in this COVID policy making process. So the governors, they on one hand issue policies directly through executive orders and so on. And we take these data to annotate the social distancing policy strictness. And then, so this is obtaining one of the data. And then we also notice that governors try to maintain a positive political like public image. For example, they would do a lot of PR of their actions. And then we try to see the public opinions through COVID tweets addressing the governor explicitly. So this will be a subset within all the tweets we get. And then specifically to automate this process, we fine-tune a COVID Twitter BERT, and then also like apply it to this Twitter data set to obtain the sentiments. So we can see that there are a lot of tweets, like many of them are quite negative, like such as this complaining the restrictions to shut down bars, and also another really angry tweet against the governor. So when observing these data, we also accumulate a stronger intuition that like politicians want to minimize such like angry voices and make them look better. So given all these motivations, now we dive into step 2, like causal analysis. So here we first specify the variables. So we have the cause, COVID tweets, and the effect, social distancing policy strictness. And then the confounders can be COVID cases and a bunch of other variables we collected. So in the ideal setting, causal analysis is about if we want to know how cause affects the effect, then we want to intervene on the cause, which is Py given due X. However, many of the cases, including this study, were not able to do the intervention. So we would shift to the observational data, like the method on observational data. Specifically, we use probability distribution in a special setting. So there are two ways that X affects Y. One is through the direct causation. And then another way is through the common confounder Z. So there's a backdoor pass from X to Y through Z. So the main idea is to block this backdoor pass so that we can turn this intervention to just probability distribution. And then we estimate the causal impact of X on Y by comparing the expected value of Y given due X equals 1, minus the expected value of Y given due X equals -1, which is a negative sentiment. So when checking out the causal impact of the public opinion on the policies, then we take out, we find the top 5 states with the strongest causal impact. And when we look into these states, Colorado, Massachusetts, South Dakota, Texas, and Florida, we found that there's a clear alignment between people's opinions and the COVID restrictions in these states. So 2 of the Democratic states, they have a high support rate, and the policies align with people's opinion in the way that most people tend to be supportive of the restrictions. And on the other way, for the Republican states, the policies align in a different way, since the general sentiments want to refuse the restrictions. So these states tend to be much looser in COVID policies. And this work is sort of one of the first attempts in our general mission to combine the 3 areas: NLP, causality, and social good. And we also welcome more efforts into the initiative of doing more NLP research that have good social impact. So feel free to follow NLP for Social Good's website and Twitter account. Thank you for listening.